Thank you very much. It's Ruben Segarra. My mom is Montelara, so my second last name is Montelara. I want to thank the appreciation of Libby and James for the opportunity to present this morning. And I want to share some of our experience in Puerto Rico from the perspective of the concrete industry. I want to share some of the words that Pepe shared with us last year on the Seminario de la Beca Ramón Carrasquillo. And it said, Ramón, known to his friends as Mongui, was a tireless educator, researcher, producer, and a concrete consultant for 45 years. His expertise in concrete was recognized and appreciated worldwide. He was larger than life, always with a big smile, impeccable wit, and generous willingness to help everyone, everywhere, without expecting anything in return. Beyond his expertise, technical achievements, and contributions to the concrete industry, through research and consulting, Ramón personally impacted hundreds of people through his jovial and generous mentorship, spanning multiple continents. His commitment to the Latin American chapters of ACI was unparalleled, assisting them, participating as a speaker, and sponsoring them for several decades. More than 35 years ago, Ramón, together with the Puerto Rico Concrete Association, established a scholarship fund to help economically disadvantaged students pursue engineering degrees. Countless engineers, material scientists, academics, and others in the field can attest to Ramón's generous heart and his exceptional ability to convey knowledge, wisdom, and guidance in his teaching. Though he will be deeply missed, Ramón will always be remembered, and his legacy will endure. 2024 was very difficult for our family in the concrete industry of Puerto Rico. We lost a very young, dedicated, and a hard-working professional, José Miguel Mejía Borrero, father of Sebastián Mejía, partner of life of Anabel Mergildo, our president of the local chapter in Puerto Rico. His departure, as the same as Ramón, was a very, very great loss. He was a very close apprentice to me, both professionally and personally. He was a friend. He was part of my extended family. We will always remember him for his big smile, his happiness, and may his legacy continue. What we have here in these two pictures is a very good example of a mentorship and a mentee. Ramón was always encouraged us to be responsible professionals and to teach others and what we learn and practice. Jose and Anabel started a mentorship program at the ACI Puerto Rico local chapter to help students on their path for a professional life and inclusion in the industry, always with the support and guidance of professionals like Ramón and Pepe, among others. Their impact in the industry will keep living and will be extended to other professionals. That is the desire and reason to continue contributing to a better industry. As the same as other of the professionals that present this morning, all of the speakers, I think that, and I now can be in my mind that to work with Ramón, you have to get dirty first. I remember when I started in 2003 at Ready Mix Concrete, my first, one of my, don't laugh, Fernando. One of my first assignments, being a technician, a lab technician, and also an engineer student, was to start working with fly ash. In 2003, we started working with fly ash, just breaking bags and dispatching to the ready-mix trucks. I don't know how many cubic yards we did like that, but was so many. It felt so many. I still have one of the knife that I used to break the bags. So I want to share this morning, I want to share some of the learnings that I got from Ramon, what he advised me on different projects and different areas. Part of the subjects or issues are going to be construction specifications, quality control, quality assurance, acceptance of concrete, QC plans, and lessons learned on maturity testing and mass concrete temperature control. Contract documents are part of the plans, or plans are part of the contract documents, technical specifications, the legal part, and those are made to ensure that the quality of the workmanship, control of the tolerance, and or materials necessary to carry out and finish the work comply as specified and will be performed according to the designer's intention. Construction specifications should establish the acceptance parameters. They should be easy to understand. Something that always Ramon was advising us is that if there is a specification that is not clear enough, just call out, make the call, make it to have it clear before doing any activity. They can be prescriptive or performance-based. They provide the guidelines for the materials that we're going to be using, construction methods, methods for measuring the compliance with the specifications, testing requirements, and at final, the payment for each of the items. Quality and profit are hand-to-hand. The contractor may pay for the cost of control of a quality control system to provide an appropriate level of quality, or the contractor may pay for the lack of control of cost associated with a poor quality in the construction, make it in more repairs, patching unacceptable areas, removal and replacement of concrete works, time impact on the construction schedules, and high litigation cost. This is something that I always use in my presentations, that we need to think quality. And the quality is not only part of the quality control department of the contractor or the concrete producer. Quality control is a matter of everybody in the team of the construction: designer, inspectors, quality assurance, suppliers, producers, everybody. We should do it right the first time. We don't always get a second chance. Pre-construction meetings with QC and QA teams. These meetings should have representatives from QC and QA before the construction begins. It's where we review all the project requirements, review the action or suspension limits for any activity, identify and clarify any mismatches or articles that are ambiguous on the drawing plans specifications, review the handling of the test results that are in non-compliant, review the chain of command for decision making. Some of the times you can have a report that is not favorable for the contractor, but if there is no decision maker, then you can delay the time of the project just because there was nobody to take the decision. Establish the QC and QA plan for data review and management of the project, and it should be involved all the parties: the project manager, the engineers, the owner administrator, the owner's representative, QC managers, contractors, subcontractors, testing labs, suppliers, etc. The cost of poor quality, what means for the owner: loss of income, operational delays, reduction in the useful life of the structure. In 2018, I started working with a contractor at the airport in San Juan in Puerto Rico, doing the concrete pavement for the taxi lane November. That's the taxi lane that connects both runways. And at the time that I entered as a QC manager in that project, the contractor was very delayed with a lot of non-compliance because of the soil compaction, the P209, the subgrade, the P209, the CTB, and we entered to try to put everything together, try to start again and do it the right way. What means poor quality, what means for the contractor? Corrective actions that are sometimes very expensive, partial payments. I don't know if there is any contractor here today, but everybody wants to get paid for 100%, not with discounts. Cost of claims, and at the end, liquidated damages. In that project that I was on 2018 through 2020, we end paying $1.5 million just in liquidated damages. And that was just because I was there. So I wasn't the owner of that liquidated damages, but I saw the certification, the final certification of that liquidated damages. I was there, so it is true. What we should know before we place concrete, we should know tolerances, and we have those guides in ACI 117. Where are the installation instructions for the reinforcing steel, the sizes, the position, quantity, according to shop drawings, make quality control and quality assurance of those shop drawings that are clear for everybody to work it. What's going to be the cover for the concrete and the formwork design, the distance between the face of the exposed surface and the soil and the forms, depending on the structure exposure. What are going to be the soil conditions, the compaction, moisture barriers, etc. On the guides for designing and specification, there should be comprehensive communication. Sometimes we lack on communication. I think that Ramon, one of the things that we can have learned from him is that we need to be very clear when we communicate. And we need to communicate in the whole team between owner, designer, structural engineer, architect, constructor, concrete producer. Part of the concrete specifications, and this is very general, we can have guides from the ACI 318, the 301, 305, 311, ASTM C94, where we can, on the specification, we should have the compressive strength, the requirements, slump, workability, that can be easy to adjust, easy to consolidate, temperature. In our case in Puerto Rico, we are classified as hot weather concrete. So the hydration of the cement and the condition of the temperatures and the admixtures that we use for that delay in the hydration and those retarders are very, very important. Density or unit weight of the concrete, so we know that we are inside of that required yield. Air content for durability and workability, and the water cement or water cementitious ratios. We need to know what water cement ratio we need, what kind of slump we have. Because sometimes we have specifications or drawing plans that request 3 inches of slump for a wall. But we know that in a wall that could be 6 inches of thickness, a concrete with a 3-inch slump is not going to be that easy to pour. So we need to manage those information, what kind of admixture we are going to use to make it more fluid to go inside of the formwork. This is a very good example of when you need more fluid concrete, but doing it, as Julissa said, not using water, using the right admixtures to make a better fluid concrete. If I have a water cement ratio requirement in my specification or in my drawing plans, I should know what I should expect on the compressive strength. It's not the same as asking for a 0.45 water cement ratio and ask for a 3,000 psi on strength, because that doesn't match unless we put a lot of air or any other cementitious material that can make a lower compressive strength. So we need to know how it affects, also in the durability. In Puerto Rico as an island, we have very, the resources are not like on the mainland. So we need to use what we have. In the past maybe 20 years, we got quarries with very good quality. Now on, we have to work with what we have right now. So it's not a matter of that any sieve on the gradation is out of the limits. If it is consistent and it's always like that, you can work it out. And Carrasquillo always tell us how to optimize our mixes and also how to work it even when one of the aggregates are out of the limits. How you can mitigate those characteristics. So we have made a lot of usage of different spreadsheets, different optimization softwares to make it work. Selection of your proportions. It depends on what the structure that you're going to be constructing. For example, if you're going to be paving with a slip-form paver, then you're going to need an amount of aggregate, a coarse aggregate, and the size of that aggregate is very important. But again, because of the resources that we have in Puerto Rico, sometimes it's not going to fit those tolerance, those limits. So you have to work it out and start mixing different sizes until you get to the optimization. Once you get to the job site, then is the acceptance testing. Concrete sampling is just as important as the test performed on it. Competent, educated, and certified staff is required to ensure that processes are done correctly. The technicians must understand the meaning of the results at the time of the testing. What is a slump out of tolerance? What the concrete is telling me? What the unit weight is telling me? It's not a matter of just reporting a number. What is telling me is inside of the tolerance or not? And if it is not out in the tolerance, why is not? And make the proper adjustments. Air content out of tolerance, temperatures are out of tolerance. In Puerto Rico, with the Puerto Rico Concrete Association, we have the certification program from the ACI, and these are part of the 5 certifications that we can provide to the concrete industry. With a quality control program that you can put into work at the job, you have to create a plan where each person knows their role. This is key. This is a key element. If everybody knows their role, once you are executing at the field, then everybody knows what to do. The time for details, clarifying doubts, discussion of the rules of the game is days before the concrete placement operation. It's not at the time of placement. At the time of placement is go and execute. It's not to clarify anything. And the whole team should be on the same path. The day of the concrete placement is to execute in an acceptable way as planned. Use of concrete placement checklist. Always Ramon was asking me to make a checklist. Remember, it's not only you. You have a team working with you, so everybody needs to know what they're going to be inspecting, what they're going to be checking. At the airport, how much beams do you need for field testing? How much beams do you need for acceptance? How much is going to be the frequency for testing the slump, the temperature, the air content? At the concrete plant, how much technicians you're going to have just to check the concrete before they go to the job site. So it's a matter of trying to mitigate and prepare before any activity. Once you have your beams or your test specimens, how you're going to manage them from the job site to the testing lab. Quality control charts. Check on your information. Have it on hand that everybody can see it in an easy way. You don't have to know each of the parameters or the right numbers. In a matter of just seeing the graph, you can see, hey, that's something that is out of tolerance, or that is closing, or if it has a pattern going down, going up, whatever. As part of our quality control plan, for example, in the airport, evaporation ratio, the measuring, it is very important to check those concrete, when to start curing, when to cover the surface of the concrete, so you have to prevent those shrinkage cracking. What's going to be your equipment for concrete installation? What's going to be the equipment for texturing the exposed surface? Your curing plan, how you're going to cure your concrete, and that your curing plan is effective. Sometimes, right here, you see this pavement that is almost white, but there are some times that those sprinkles on the spray nozzles on the curing cart, they get clogged. And then you start seeing that it's not covering enough. If there is nobody looking at it, you're going to be paving 100 feet and you're not doing the right way. But also, being in an island, we need to predict any rain events. During the night, it's a little bit difficult, but we have a lot of, in our phones, smartphones, we have different applications that can advise when it's going to rain, and you can plan ahead. But there are times that you cannot. So you have to be prepared with some plastic and cover your area. After the rain event, just check if, for example, in this one, I think that we tear off the whole lane because it was very affected. But you need to plan ahead on things like that. And now, from the lessons learned from Ramon Carrasquillo and from Fernando that he is here, some of the testing that I started working with it from 2004, 2005, was maturity testing in Puerto Rico. And there was a lot of presentations of Ramon talking about maturity testing, and there is a picture of a guy just down with the back. You only see the head and the back. That's me. I'm the model. So I remember that every time that I have any maturity question or something regarding maturity, I talk to Fernando, to Ramon, and we learn a lot about that. This is a project of a wastewater treatment plant in the southeast of the island in Puerto Rico, where we have around 8 water tanks that are considered mass concrete. Segarra Engineering, my firm, is working on all the testing for the concrete and also the maturity and mass concrete control. And I remember when doing this, I talked to Oscar in San Francisco. And also, you know, it's like we check with Oscar and then check with Ramon. Ramon said, okay, check on ACI 207. What it said, Well, yeah, I know. No, let's calculate it. And he took a pencil and a paper, tun, 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 tun. These are going to be your temperatures. Well, those were our temperatures. We did a QC plan for the whole project. We stick to the plan, and also the QC plans at projects are not just a document. It's a live document. If you need to go back, update, recheck your plan, do it. What's gonna be the curing method for those mass concrete? In this case, we use white blankets, wet blankets, and foggers all around the structure for all the foundations. And if you can see here on the charts, we were under the limits of the gradient limits between the centroid and the surface, and also the limits of the maximum temperatures, using slag cement, using very low cement content. And we achieved the maturity testing with our mixes. Also, there was another project. This was on last year. We placed 2 cap beams in Utuado, that is on the PR10. It's a road that is going to cross someday the whole island from the north to south. And on this one, we were working with the specifications for the 934 of federal lands from Federal Highway. We use a class 5 bridge element concrete class, compressive strength of 5,000 PSI, permeability for the ASTMC 1202 of 1950 columns, a maximum water cementitious ratio of 0.45, maximum cementitious content of 700 pounds, shrinkage reducing admixture 1 gallon per cubic yard, corrosion inhibitor 3 gallons per cubic yard, and the maximum delivery temperature was 85, maximum temperature on the concrete 160, and the maximum differential 35. What we planned with the concrete producer and with the contractor was to use type 1-2 cement from Argos, 40% of slag as a matter of substitution. The delivered temperature was 70 degrees, using a lot of ice per cubic yard, and a slump in the range of 6 inches plus minus 1.5. As part of the mass concrete control, the contractor make like a invernadero. ¿Cómo se dice invernadero? A greenhouse. They make a greenhouse in the whole around the cap beam, and they put steam water inside of the greenhouse. So they manage all the temperatures of the ambient and the structure, and these are some of the numbers that we got on that project. So everything was as per the plan, and the contractor did everything on his hands to meet the specifications, even though that they did a lot of work all around of what they need to do about the concrete. And pretty much that's it. Thank you very much.